I think these are the 10 most important steps when you're learning Unity. The first is just basic programming. I mean, you can't really get around this. You basically have to know how to program, especially in Unity. I mean, it's just such a core part of pretty much like every single game that it's kind of impossible to make a full game without it. I know that there are some projects that have probably done it, and a lot of people like to use visual scripting languages. Like Unity has this thing called Playmaker, this thing called Bolt. They basically make it so you don't actually have to type out a line of C# code. You can just connect together nodes in this kind of graph. And yeah, I guess that's technically like not coding, but at the same time, the logic in all those Playmaker nodes is exactly the same as the logic that you'd be writing if you were actually typing out C#. You definitely don't have to become a software engineer just to make a game. In fact, Unity and C# only requires you to learn what I would view as pretty basic programming concepts. And if you've got that foundation down, I think it enables you to do a whole lot more. I think it enables you to do a whole range of projects, especially on the smaller indie scale. If you're a solo developer, you definitely don't need to spend multiple years learning all the things that like a computer science degree would require just to get your indie game out there in the world. That being said, there are like at the entry level, there's tons of great resources to learn C#. One channel that's really prolific is Mosh. I mean, just go check out Mosh. He has an hour guide. It's completely free. I'll link it in the description. He's a great teacher. If you don't prefer video guides, then Microsoft themselves has a written step-by-step that'll take you through all the things. Basically, if you can get to the point where I can say these things such as variables, types, loops, conditionals, basic object-oriented programming, what's a function, what is scope, what's a class, what's an object. If I say all those things, and you don't even have to be super familiar, you're just like, yeah, I did like a practice example on that, or I did a question or problem on that, then you're good to go. I mean, you can do most of the learning in Unity. You can use games to propel your programming career forward. It's just, if you walk into something like Unity with no programming experience, there's gonna be so much syntax to learn and so many other things that it's gonna make it pretty impossible to actually get started, because you have to learn the Unity syntax, but learning the Unity syntax requires applying the basic programming concepts, and if you don't have the basic programming concepts, you're just gonna feel stuck and you're gonna feel demotivated. So I know learning programming for a lot of people is like super boring, and they're trying to find any way possible to like skip around it, but trust me, just put in the few hours, get the basics down, and you'll be a lot more motivated for the rest of your journey, and it'll be just better overall. All right, the second thing is like Gameobjects and Prefabs. So basically, the second you get into Unity, you see this blank screen. You've got a section on the left, a section on the bottom, and a section on the right, and they're all different, and you don't know what they mean. But what you can do is you can go over to the left section, you can right click, and suddenly you get the create option. And the create lets you make a whole bunch of different objects like cube, sphere, cone, honestly, plane. There's a bunch of Unity primitives, and then you see a whole bunch of other options that you don't need to worry about right now. And you create one of those objects, and if you click on that object, then immediately appearing on the right side is the inspector window, and the inspector has the properties, and what you just created, that primitive shape or whatever, is a game object. And a game object is just, to me, it's the core unit of Unity. Well, meters are the core unit of Unity, but the core unit of Unity in terms of what are the things that make up your games, what makes up the enemies, the players, the levels. It's all game objects, every single one of them. Understanding the building blocks that you construct your tower with to then make your wonderful, wonderful game. And basically, all a game object really is in Unity a flat list of components. I mean, if you create an empty game object, which you can do in Unity, all it will have is a transform, which is just a position in a three-dimensional space. It's nothing but a position. I mean, the game object is literally empty except for that position. And then everything else that you add to that object is a component that you put that adds functionality. So for instance, you can add the mesh to view it, or the collider to make it collide with things. So once you've got Gameobject down, you understand that these are the building blocks of Unity. You've got to understand prefab, because prefab and object are like so intrinsically connected that it's impossible to ignore. A prefab is, in the simplest terms I can describe it, a blueprint for a certain type of object. So for instance, if I say I have a hamburger, if I have the blueprints for a hamburger, like what does every hamburger have? It has bread, lettuce, tomato, beef. I have that blueprint laid out for a hamburger. That's the prefab. And then from the prefab, I can create actual hamburgers in the world. So if you give me the hamburger blueprint, then I can actually create like a real hamburger in front of me. And the real hamburger is the Gameobject, and the blueprint is the prefab. Now, you might not be connecting, okay, why are blueprints actually important in game development? Well, think about if you had to make every single object in your game without a blueprint. I mean, it'd be a nightmare. You'd be like copying enemies all around. To make like 100 of the basic enemy object, you have to duplicate it just all over your scene. And then if you want to use it in a different scene, you'd have to copy it over there, and you'd have, I mean, it's just a nightmare. And think about it, if you had 100 little basic enemies, and you wanted to change the basic enemies from just walking to running. Like, you just want to make them a little faster. Well, guess what? If you didn't use blueprints, you'd have to go and select every single enemy and then change the parameters. And there's some parameters that you'd change where you'd actually have to go individually into every object and click 100 times to change that variable. That's a no-go. We're not trying to do that here. So with the blueprint, every time you want to create that basic enemy, you just drag an instance of the blueprint into the scene. Enemies for days. I mean, you just spew those things all over the world. And you can change the blueprint, and this is kind of a magical blueprint. It'll automatically update every single enemy in the world, update every single instance of that object, which is super awesome. It saves a ton of time. It makes it so that every change you want to make is so much easier. And then you can, if you want to make different types of enemies, you can just create different types of prefabs and then populate them into the scene with that. It's basically, if you're not using prefabs, it's like not programming with data structures in a normal program. It makes it incredibly inefficient, and just do it. Just do it. Just look up Unity prefab. Once you know what a Gameobject is, it'll help you out a lot. The third thing that you need to know is, okay, what are the components in a Gameobject? So you understand that a Gameobject is a list of components, and you understand that the prefab is the blueprint for the Gameobjects. But okay, what are those actual components? Because if you create an empty object, all you start with is a transform. Well, basically, the component, there's tons of components. I mean, Unity is stock full of components, and that's what makes it such a powerful engine. Because every component you add to your Gameobject, you're basically eliminating like many hours of work that it would have taken to make that yourself. I mean, try just making a physics system by yourself. There's a reason that people use engines like Unity, and it's because they've got all these great components. So the components that I would say you've got to be familiar with if you want to make any kind of game in Unity. Rigid bodies. Rigid bodies are key. They're basically like the actual physical objects in the world. They have physical properties. They are affected by the laws of physics. You can make them experience gravity. You can make them experience forces. So if you want to, like, imagine pushing something. Rigid bodies can be pushed. I mean, points, transforms in the world, they can't be pushed. So if you want physical objects in your game, you need to understand rigid bodies. Second thing, colliders. Colliders are what enable objects to, wait for this one, collide with other objects. So there's a bunch of different colliders. There's box colliders, capsule colliders, sphere colliders, composite colliders, terrain colliders. Basically, imagine objects have shapes. I know, crazy. Colliders are expensive for the computer to make, and if you can't just assume that every single object will like have a collider that matches its shape perfectly. So me as a human, I don't have like some fancy human shaped collider. I'll probably just get a capsule and put it around my body, and there will obviously be space between me and the edge of the collider, but that is way better than trying to render a collider, both in terms of processing and in terms of gameplay. Because guess what? 99% of the games you have don't have colliders that perfectly line up to the outline of your object. Because players, no matter what they tell you, no matter what they say, they don't want the game to be fair. They want it to be unfair in their favor. So when they play, they don't want a spike falling from the ceiling that like glances their side. They don't want that to kill them. They want it to be a gift that we developers give to them to allow them to live, even though they really should be dead. So you look at the colliders for some games, they're just like tiny spheres or cubes inside of the actual player. It really has to be a direct hit almost to be hit by the enemies or hazards in the world. If I just lowered your self-esteem as a gamer, then I have one thing to say to you, and that's get good. You gotta know what cameras are, just because if you don't have a camera in the scene, you literally have nothing. There's no perspective in the scene. It doesn't come from magic, it comes from cameras. So you've got to understand what cameras are and how they provide the viewpoint in your game. You gotta understand just basic lights. Unity will provide a skybox that provides some general lighting, but you've got to add lights to certain places. Meshes and sprites. So the rigid body and the collider, those things aren't actually rendered in the camera. You can see them in the edit view. They're like green wireframes or little symbols. But the actual things that get rendered are meshes if you're in 3D and sprites if you're in 2D. So make sure you know what a mesh renderer is, or just what a mesh is in general if you're making a 3D game, and what a sprite is, and what a sprite renderer component is in Unity if you're making a 2D game. And then audio listeners, I mean, sound doesn't just play in Unity. You have to actually set up a component called an audio listener to play. I'll talk more about audio later. Be familiar with the audio listener component. It's the most basic way of playing sounds in Unity. And then the transform component. The transform component is responsible for keeping track of the position, rotation, and scale of your object in the game. Position, rotation, and scale are three things that you're gonna have to be really familiar with when you're manipulating objects at all. So just be familiar with the transform component. I mean, it comes with every single game object, so it's easy to take for granted, but just take a second to like understand what's going on there. All right, now we get to part 4. This is pretty much one of the most essential things you can do. It's the controls in C# for each one of the components. In the right side of Unity, when you click on the object, you can see the inspector for a lot of things, and you can manipulate properties, like you can manually change the position of game objects, you can rotate it, change the rigid body properties, whatever. And you should do that whenever possible because it's easy and you get real-time updated results. But the fact is, one, not all properties of the components are actually visible to the inspector. Some of them are only accessible via script. And 2, you can't modify the properties of an object in the inspector during runtime. Once you hit play on your game, it's done. You can't modify the inspector. When you build your game, when you run the exe, there's no inspector for the player to change the properties to make your game run for you. You have to do all that logic during the gameplay of the game via the script, via the C# scripting, via the actual code. You add them just like any other component with the add component button, but then you have to go to the scary territory of make my own C# script. I know. It's a big leap to take, but you just gotta do it. You gotta do it. So once you make your own C# script, in that component of the object, you can then start referencing other components and start manipulating the other components by getting the methods of those components. So that's where all the logic goes. You just add it as another component of the game object, but it's your own custom C# script. You have to hook the components themselves into the C# script. So you have got this, let's say you wanted to push a rigid body. You wanted to add a force to a rigid body. So you gotta reference the rigid body in the script. So there's 2 steps to this phase. One is finding the reference to the components in the script. So there's this rigid body that exists, and how do you actually reference this rigid body? How do you know that it exists? You can't just say rigid body. The computer has no idea what that means. Which rigid body? Where is the rigid body? So you've got to learn that there are 2, well, more than 2, but 2 main ways to do this. One is making a public rigid body variable, and then when you make a public variable, it'll actually show up as a property in the inspector, and then you can drag whatever component you meant to reference in the script. You can drag it to the slot in the inspector, and then the computer will automatically know what's going on. Boom. The second main way is using a private variable, meaning it won't show up in the inspector. However, you can use various methods that are part of Unity, part of the Unity syntax, to then find them. This will be get component or get object of tag or type or whatever. Find objects in scene. There will be multiple methods that you can use to find objects like that, then you can pull them into your script. The second main part that's really important is that once you have the component in the script, referencing the component's methods that allow you to do things. So for instance, to go back to the rigid body force push thing, all rigid bodies in Unity have a method called add force. So when you code, let's say you call your rigid body RB, that's a common convention. You can say RB dot to access the methods of an object. Then you can do add force, and then add force is a method of the object. So since you know what methods are, you'll know that we'll need the parentheses next to that, and then have the parameters for that method in the call. And then we'll get to add force, and we'll get to, in the parameters, tell Unity how to add force. So do we add a lot of force? Is this a big push? Is this a little push? What mode do we add force in? Is this an acceleration that should consider the effects of mass? Should we not consider the effects of mass? Do we want to distribute force over time, or do we want to impart a huge impulse on the object where all the force is just like explosion? Speaking of which, there is a add explosion force method in Unity. I recommend experimenting around with that. You can achieve some pretty cool things. So yeah, just be super familiar with the methods on rigid body, collider, transform, on basically take all the components that you learned when I was talking about essential components and make sure you go to the docs page. I know, documentation. You're like, documentation doesn't make sense. I know, it's fake, it's fake. No, it's not fake, it's real, it's great. And I want you to go to the documentation for every component and look at just the top methods. Like usually, Unity developers made their documentation with new learners in mind. Just look at some of the methods and pick out what's obviously the major functionality for each component. So for a transform, if it's responsible for the position and the rotation and the scale, then yeah, you should find the methods that directly change the position, rotation, and scale of the object. If a rigid body is responsible for giving Gameobject physics properties, then yeah, the things that affect forces towards the object or force properties of the object, those are going to be the most used and important methods in the rigid body component. So use common sense, make sure you understand what the purpose of the component is. I mean, finding the most important methods is probably a test of how well you actually understand the purpose of the components themselves. So make sure you understand the purpose of the components. Think about if you were given this component and asked to actually use it in a game, think about some common things that you might use it for just in a generic game, and then find the methods in the documentation that would accomplish that task for you in the game. Keep a little list. I don't know. Eventually they'll become so second nature that they'll have it all memorized. It'll be crazy. But right now, like, write some of them down. Just like memorize the short descriptions. Just keep reading them and just make sure you're good to go on that. All right, so yeah, learning. Here's a marker for you. Once you know the methods for the components and you already know what game objects and prefabs are, you're ready to create. You can create your first actual real game. It's great. Everything else doesn't matter. 5 steps to learn Unity. No, the rest of this stuff matters a lot. But what you can do is you can go into Unity. I want you to create some cubes and some planes, and maybe a sphere. I mean, that's up to you. Just add in whatever the shapes you want. But I want cubes and planes. And now that you know position, rotation, and scale, and now that you know the basic components, and you know how to make prefabs, and you even know how to link those components from the inspector to the script, I mean, you're rolling here. You can put game objects into your scene, you can give them physics properties, and then you can add the script components, you can add the predefined components, and then whatever's missing at that point, like whatever additional behavior you want to make your little ball game, you can add via the custom scripts, which are additional components, and you can make your little game. I mean, this is gonna be a really simple game, and it shouldn't take you more than a day. Like, just spend a day on a game or something. Game a day. Game a day. That's a good strategy. Do something really simple. Make a little soccer clone. Make a little spaceship game. Make a little, I don't know, you're the game developer. You gotta come up with the ideas here. This is where the creativity comes in. But just play around a bit. I mean, seriously, once you get to this point, you can do a lot of stuff. I mean, it won't look great. You'll put your game on it and people will be like, those are the default Unity assets. And you'll be like, I know! But just do stuff. I mean, you're at a great point here. Step 5. The odds are is that your game has some sort of setting, some kind of location, or even for games without location, like Tetris, there's a board where the pieces of the puzzle go. Now, just using the default Unity tools, creating a full level or scene like that would be pretty difficult. I mean, you'd try to align objects and they wouldn't really fit together. There'd be cracks and crevices, and the whole thing would really just be a mess. Fortunately, there's a built-in system to Unity for making levels, at least for 3D games, and it's called ProBuilder. Now, ProBuilder used to be paid. People had to pay something like $70 for it. They all complained, but finally Unity listened, and they added ProBuilder to the program as a free tool. So what ProBuilder essentially allows you to do is create objects in a way that's actually well suited for level development. It accomplishes this in a couple of ways. First, you can edit the geometry of individual objects. You might have noticed that when you create a Unity cube, you can alter the rotation, position, and scale of that cube, but you can't move any of the vertices independently. Well, in ProBuilder, you are able to do this, edit objects to your heart's desire, and you can use it to create much more complex shapes and actual structures. The other major benefit of ProBuilder is that it works with another thing called ProGrids, and it snaps everything you build and make to a grid in the world. This is essential because it makes lining things up a cinch, and it makes your entire world and scene actually look structured and organized, as opposed to a complete mess. When you're ready to make real levels, experiment with ProBuilder and see what kinds of worlds you can create. Once you start using it, the possibilities
explode in terms of the detail and depth of your level. Now you might be thinking, I don't want to make a 3D world. I just want to make a 2D game. Well, even then, you'll still have a setting. And there are other tools that you can look at to use to build your level. Chances are, if you're making a 2D game, you'll be able to use tiles of some sort. Tiles are nothing more than collections of 2D pixels that can be repeated across part of the screen. For instance, if you have a ground, chances are parts of the ground are actually repeating as tiles. Just think of the work that it would take to create the entire ground for a whole game and make every single segment unique. I think some people would consider that a form of torture. Now, fortunately, Unity has a built-in tile map system, so you can create these tiles, you can draw them, and then you can actually paint them onto the scene to create whatever world you're going for. Now, a lot of people complain about Unity's tile system, and I personally think they've done a good job of updating it over the years. There's also pretty amazing third-party software to help you out. I encourage you to check out Tiled, which is free software developed by one guy over the course of a few years. It lets you seamlessly paint and build tile maps and then import them directly into Unity. With software like that, you could create any 2D landscape that you could think of.
Let's say that you need detail. You need more fidelity in your Pro Builder model. You want maybe real character models or something. You've got to do actual modeling. It's like step 5.5. And I call it 5.5 because it's not in Unity. You've got to go outside of Unity. You've got to use a real 3D modeling program, which can be pretty scary and are often pretty difficult to learn. But you want to be a game developer. I mean, making models and making 3D assets is such like a core part of that if you're trying to make a game by yourself, it's kind of impossible not to do. So you've got to learn a modeling program. I pretty much overwhelmingly recommend Blender, even though I'm sure you've heard terrible, horrible things. Blender is super complicated to learn. It's not as functional as Maya or Autodesk. All the hate. And all of that comes from Foundations of Truth, and the long history of Blender definitely has had lots of problems. But in its current state, especially with the latest 2.8 Blender release, the software is actually super approachable. And I mean, yeah, I definitely recommend that you try to learn it. It's almost too functional. It does too much. It has too much power, but definitely try to learn it. In fact, just go to the donut tutorial. Just search like the donut tutorial Blender. I promise you won't be disappointed. That tutorial will give you all the basic fundamentals of Blender that you need, and it'll actually branch out into specific other tutorials that you can follow. It's great. You'll have a great time. You'll make an awesome donut. I mean, what's not to love? So do that. Learn modeling. Get good. And then that's a way you can add more fidelity to your project. And if you're 2D, then you'll need to definitely you'll need to either make pixel art, which you can do with a computer and a mouse, or you can hand draw stuff. And at that point, if you have a digital tablet, great, go for it. Photoshop's good, Clip Studio Paint. There's plenty of digital drawing programs for you to create assets. Or you can hand draw things and scan even. The advantage with working in layers and creating something, say in Photoshop, is that it gives you more flexibility for animation, which I'll talk about later. Pixel art, you might have to even animate frame by frame, which means drawing each pose as it comes in the animation, which can be a lot of work. I mean, it looks great, but it's a lot of work. Shaders are essential. They're super essential, and a lot of people don't even know what they are. I mean, they can kind of hear the word shader and think, oh, that's something to do with graphics, right? But they don't really know anything about shaders or how to implement them. But they're huge. They're essential, and they're huge and essential because they're efficient and they have drastic impacts on the visual of your game. So there's a lot of ways to add detail and texture to your game. I mean, you can make higher fidelity models, you can make a bunch of textures that are HD. I mean, that'll take you a lot of time, so just be careful with what kind of commitments you get into there. But shaders, you can apply a shader to any material that you want. And so essentially you can choose which shaders affect any surface in your game. And that's a big deal because shaders pretty much wholly determine how light and how color interacts with your objects. You want to make that super translucent water, shader. You want to make that Wind Waker clone, shader. You want to make that Breath of the Wild cell shaded gloriousness, shaders. You wanted to make your really artsy indie game with super like edgy lines and outlines over each character and everything super dramatic, shaders. You want to make that low polygon aesthetic with a bunch of bloom lighting and a bunch of glowing everywhere, everything's glowing all over the place and it's like a fairy wonderland. Shaders. I'm telling you, the style, the aesthetic of your game comes from shaders. So I'm saying all this, how do you do shaders? Well, fortunately Unity recently implemented a built-in tool called Shader Graph, where you can use basically a node editing system where you can link together components of the shader to produce the desired output. I'm leaving it vague. I know that doesn't make sense at all. Basically what I'm telling you to do is go to Bracky's channel. If you don't know Bracky's, just go there. I mean, he's full of wisdom. He will teach you everything in Unity, every specific concept. So take all the concepts I'm telling you here and then just add Bracky's to the search query, and then Bracky's will tell you how to specifically implement those things. He has a video on Shader Graph. He'll teach you how to do it. You'll be on your way. You'll be able to make your artsy indie game. What else do you want? So lighting. Lighting, I mean, shaders and lighting are like intertwined. Shaders affect how light interacts with your environment. Lighting, it literally is the light present, the light sources present around your environment. If you don't have any light sources, you either have accepted the fact that your game is evenly lit across the entire game, which, hey, I mean, that could, there are plenty of games like that. Or you admit that there's no light in your game. And if that's the case, then I'd love for you to drop a link to your game down in the comments, because if it's anything other than a black screen, I'm very interested in how you've managed to transcend the laws of physics. Basically, without light, we see nothing. It's all dark. No color, no nothing. And the ways that you add lighting, I mean, obviously some lighting is way better than no lighting, but the ways that you add lighting drastically impact the look of your game. And this is right up there with one of the essential components next to shaders because they're also so efficient and they have such drastic impact. You can put lights anywhere. They affect all surfaces. And the better your lighting, the better your entire game looks and the more realistic your game looks. The biggest thing that separates a lot of like good-looking games from great-looking games, games where you say, oh, that's nice, to games where it's jaw-droppingly realistic, is how much effort and time was put into the placement of the lighting and the type of lighting that was added. So you're gonna get into a lot of thickets here. You're gonna have to learn about baking lights. You're gonna have to learn about light probes. It turns out lighting, you can drop a light in there, but it's not gonna do what you want it to do. It's not gonna interact with the environment the way you want it to interact just by throwing it in there. So you're gonna have to watch a bunch of tutorials about lighting, and you're gonna learn how to actually light your environment. And Unity will admit it's a pain, but once you go through with it, your game's gonna look that much better. All right, so now we have number 8. We have animation. So yeah, you have all these static objects in the world, and if you're fancy, you have a player controller so that your character can actually move throughout the world. But if you want any sort of sophisticated movement, or if you want cutscenes at all, or if you want enemies, if you want NPCs to be waving at you like, hello, how can I help you today? You're gonna have to animate. Animate's a huge spectrum of topics. There's so much to get into for animation, and it's different depending on the medium of your game. If you're doing pixel art, frame by frame animation. If you've drawn, hand-drawn sprites, you can do this fancy process called rigging, where you give your sprite actual bones and joints. And then you can move those bones and joints to like rotate things. So then you don't have to draw every pose. You can take your rigged sprite and go to Unity's 2D character animator and literally create these bones, and then you can animate the bones themselves in whatever motion you want. no matter how demonic or contorted or terrible that may be. The same concept of rigging can be extrapolated to 3D. You create bones in 3D objects. It's probably even more intuitive in 3D than it was in 2D. So rigging and all that, it can be, if you're modeling in Blender, I would go ahead and just suggest, go ahead and rig in Blender. It's not that huge of a leap. If you're making character models, you can do that in Blender and then take the rigged models to Unity. And then to animate, there are systems within Unity. So there's Mechanim, which is a state-based animation system. So if you ever heard of a state machine, you can create a state machine of animations where you can create all the different states that your animations could be in, and you can determine the flow between those animations and how different animations can transition between each other. And then you can also control that via script. It's a whole thing. Mechanim, Unity, there you go. That's your next topic to learn. I'll give you the stuff, and then you look it up, you learn it, and you make games. In addition to Mechanim, if you want to get fancy with camera animation, there's a whole system called Cinemachine, which is a whole nother thing to get into. You can use it to create fancy cutscenes and all that. And then when you actually want to create the individual animations themselves, like say I want to create this waving animation, you can add an animator component to your object, which will allow it to be animated, and then you can create an animation, which is just something you can create, just like normal in Unity, and you can keyframe different movements over time. Now, keyframing is used in a lot of things. It's used in video editing, it's used in sound design, it's used in animation. So if you've never heard of keyframing, the simplest explanation I can give is you pick 2 points in time and each point holds a value. So let's say we want to alter the X position of me. At time 0, I put a keyframe and I associate with that keyframe the value of here. And then at time t equals 2 seconds, I create another keyframe and I associate with that keyframe the X position of here. Let's say that's 1 unit to the right. Since I have those keyframes in place, Unity, when it's moving between those keyframes, will automatically play that movement. So in between keyframe, let's say we're at keyframe 0 right now, and then we hit play, and I'll do this. And then once I get here, then we're at keyframe 1. That's the basics of keyframing. There's a lot more to it. So you do keyframing, you get your animations, and before you know it, you're creating feature-length films. I don't know, maybe your Blizzard quality cinematics. It's not that hard. It's not that hard. Also, keep in mind, lots of things are animated that you wouldn't normally think about. Not just player motions, but also just menus and stuff. So think about menus fading in and fading out, or think about health bars even, filling and unfilling. Everything that's moving visually on the screen that's not controlled directly by a movement that you defined in one of your scripts with, say, add force or move position or any of that. All that is some form of animation. And one tip I can give you is for a lot of those little animations, like the bounce in the menu or anything of that sort, look into the free plugin called DoTween. It's a free Unity plugin, and it uses what's called a tweener, which is a method of linear interpolation between 2 points to turn those super rigid movements into the super smooth movements. It's basically magic, just like a lot of assets on the asset store. And since it's free, I mean, there's really no reason why you shouldn't check it out. Number 9, audio. Do you want sounds in your game? Do you want players to actually hear? If your answer is no, then I'd like you to drop a link to your game in the comments, because I'd like to see the mute experience that you've pulled up. But otherwise, if you do want sound in your game, there's processes to learn. Obviously, creating the sound effects and the music, I mean, it just has to be done outside of Unity. You'll have to, for the music, pick up some program. You can use Reaper, which is a digital audio workstation, which has an indefinite free trial, and you can pick up some free synthesizers, some free instrument packs. You can start putting together some tunes, or you can just download some pre-recorded beats, just layer them on there, become your own SoundCloud producer, get like 7 followers over the course of 3.5 months, and then just lay out your mixtape and use that as the OST of your game. I mean, you could do that. And then for your sound effects, you can, if you have a few synthesizers, it's easy to make a lot of chiptune-esque sound effects just by playing little blips and blops. You can also get a subscription to something like Epidemic Sounds or some other service. They have a whole library of sound effects that you can use. The same applies if you really don't want to make music and you have nobody to make music for you. There's lots of royalty-free sites, some of them actually free themselves, even for commercial usage, and you can just plop in those. But then actually implementing the audio and the SFX. At the basis of it, you're going to require a lot of audio listeners for each. So every object that plays either sound effects or music is going to require an audio listener to play that. And then you can, just as with all the other components, link those audio listeners into the script and then manipulate when they actually are playing whatever sound effect. There's lots of properties to keep track of: looping, play on wake, all that stuff. But for the more advanced properties relating to the audio, anything from volume being the basic to things like the compression, the EQ, the reverberation, the reverb, the delay on your audio, you can actually do all those effects in Unity. You just have to create an audio mixer, which is an object, and then in the audio mixer, you can link all the audio listeners into different groups in your audio mixer, and you can use the audio mixer to more precisely change the levels and effects of your audio. It's super helpful, and yeah, go look up Audio Mixer Unity. All right, and the last topic is UI, user interface. I know, every game has to have it, and nobody really likes to do it. I mean, I'm sure there's people that like to do UI, graphic designers, people like that. And it's super important. Like, the difference between a game with good UI and bad UI is stark. And exceptional UI can go a long way to creating the right mood in your game and creating the level of quality that you're after. But it can be boring. I mean, it's just making buttons and sliders. It's a lot of work. You have to hook in lots of different properties to control, and sometimes settings are not as easy as they may seem. I mean, we take settings for granted in the games we play. We just assume, oh, volume controls, oh, sound effect controls, oh, difficulty controls. I mean, think about what goes into the difficulty controls. Just creating one additional difficulty mode could involve reworking and rebalancing every single level in your game. I mean, it's a lot of work, but it's necessary, and you gotta do it. And at the basics of UI, Unity again has a built-in system. When you go right-click create, there'll be a whole subsection for UI elements that you can check out. A big thing I can tell you in this high breadth, little depth video is that you want to use a canvas as the base for your UI. You can have a canvas which indefinitely overlays things on your screen. So you can have like a HUD, or you can have a menu pop up there. And then on the canvas, you want to have child objects for the canvas where you can put things like buttons and sliders, and you can create inventory slots and different images and all the sorts of stuff. And then on those buttons and sliders, you can hook the button and slider components into scripts, which then control your UI, give it the actual functionality that you want. And you can add different sound effects, different visual, you can actually add visual animations to the different buttons, and then you're on your way. Don't skimp out on the UI. You need a good UI. If you're gonna finish a game, you gotta have a UI. You can't publish your game to Steam if it has no UI. If your game doesn't have UI, drop a link in the description and I'll leave a review of your no UI game. I'm excited for that, but also just do the UI. Just put the buttons there. Once it's done, you'll be very satisfied at how much better your game comes across. All right, so that's the basics. I mean, there's a lot I didn't get into. I didn't talk about input systems. How do you actually get input from the user? I didn't talk about more advanced things. I didn't talk about the AI that you'll have to implement for things like path tracing and enemy aggro and stuff like that. I kind of left the physics and the interactions between objects to the minimum. I didn't go into, say, ray tracing or other methods of having objects interact with each other. And I mean, while we're at it, I didn't really talk about programming practice at all. I mentioned object-oriented programming, but there's a lot to it. I mean, there's advanced design patterns that you'll have to use to get familiar with things like inheritance, composition. You'll have to realize that just making all your variables public is a pretty bad idea, and you'll want to explore trying to keep everything private. Although, pro tip, you can do serialized field and square brackets around private variables. That'll make them show up in the inspector. And basically, what I'm trying to say is everything I talked about in this video, despite how long it is just the tip of the iceberg. But what matters is that if you follow this roadmap, you'll get to a point where you can make games and enjoy the process and make results that you're proud of while learning along the way. Whereas if you don't have any of this stuff, there's nothing you can actually create. There's no results that you can generate to motivate yourself, to be satisfied with your progress. And so that's why these steps are so essential, because if you don't get them, if you get stuck along this path, then you're missing out. You'll get demotivated, you'll think this is impossible, this is not for me, and you'll drop out. You'll stop making games. But if you keep yourself on a roadmap where you're focusing on the essential topics, on the things that are so necessary to learn, and making sure that you're actively making progress on every single one of those to work towards making full games, then I think you'll see a lot better results. I mean, when I started with Unity, I just kind of messed around. I followed a lot of tutorials because I thought, you know, if I just follow one specific tutorial, I'm sure they'll cover what I need to be covered. But I found that most tutorials that I watched only covered a subset of what I needed to know, and I was not good about taking a big picture approach to considering all the different essential topics that are really necessary for game development. So I hope that this video, if nothing else, serves as a roadmap for you, or a series of markers to know whether or not you're on the right track with the other tutorials and learning that you're following. Make sure that the resources that you take in are covering all of these topics, so that if you want to make a whole game by yourself, then you're actually getting all the areas of learning that you need and not neglecting any one thing. If you thought this was helpful at all, be sure to subscribe. This channel is pretty brand new, so every new supporter helps a lot. If you liked the video, be sure to like it. If you didn't like the video, be sure to dislike and comment down below to tell me why. Be sure to stay tuned for other devlogs on exciting projects I'm working on. And most of all, welcome to the herd.